So today we're talking about proving lines parallel. So we're using the same theorems and postulates that you learned yesterday, but now we're going to put them in proof form. Okay? So the first thing, they told us that line L and line M are parallel. So the first thing you want to do is go ahead and mark your picture to show that those are parallel. Now, since those are parallel, they're now talking about they've given us angle 4 and angle 6. Well, we know this is angle 4. Angle 6 is an alternate interior angle with angle 4. So we know that the measure of angle 4 equals the measure of angle 6. Okay? So from here, I'm going to go ahead and label, I know angle 4 is 9x minus 10. Angle 6 is 7x plus 8. Okay? Well, if I know those equal each other and I want to find the measure of angle 5 and the measure of angle 2, well, once I know x, I can plug in values there, and then I can figure out 5 and 2. So I would plug in 9x minus 10 equals, my angle 6 is 7x plus 8. I'm going to subtract 7x from both sides, which gives me 2x minus 10 equals 8. Add 10, and 2x equals 18. So we know that x equals 9. Well, if x equals 9, I can now plug that back in. 9 times my x is 9 minus 10 would be 81 minus 10, which is 71 degrees. So I know that my measure of angle 4 is 71 degrees. So I'd come back up here and say, okay, well, if this angle right here is 71 degrees, then we know angle 2 is a vertical angle with angle 4. So this is also 71 degrees. Okay? So I know measure of angle 2 is 71 degrees. The measure of angle 5, well, angle 5 is same side interior with angle 4, so they're supplementary, or it's a linear pair with angle 6, so they're supplementary. So I could say 180 minus 71, which would be 109, would be angle 5. So the measure of angle 5 is 109 degrees. Okay? Now, so on this one, we're looking at the measure of angle 1 and the measure of angle 6. Well, the measure of angle 1 and the measure of angle 6, those don't have a relationship. But you know that measure of angle 1 is congruent to measure of angle 3 because they're vertical angles. Okay? And then you know angle 3 and angle 6 are same side interior or consecutive interior angles. So angle 3 is supplementary to angle 6 because parallel lines mean same side interior angles are supplementary. Okay? So you now know that if 1's congruent to 3 and 3 is supplementary to 6, then the measure of angle 1 plus the measure of angle 6 is going to equal 180 degrees, okay, because of substitution. Because if these two are supplementary, then you know that the measure of angle 3 plus the measure of angle 6 equals 180. So if you substitute angle 1 in for angle 3, 1 plus 6 is 180 degrees. So at this point, we could say 12x minus 5, which is our angle 1, plus 6x plus 5, which is angle 6, equals 180 degrees. And you know x equals 10. Well, if x equals 10, 12 times 10 minus 5 equals 120 minus 5 is 115 degrees. So you know the measure of angle 1 is 115 degrees, which means the measure of angle 3 is 115 degrees. So the measure of angle 6, which we can plug in, 6 times 10 plus 5 equals 65. And you know 65 plus 115 equals 180, a good way to check your answer. So from here, we know that the measure of angle 5 is congruent to the measure of angle 3 because they're alternate interior, and it is supplementary to angle 6 because it's a linear pair. It's also corresponding to angle 1, so you know angle 5 is 115 degrees. Now angle 2 is corresponding to angle 6, so it's 65 degrees because corresponding angles are congruent. You also know that it's supplementary to angle 1 and angle 3 because it's a linear pair with both. Okay? Now, from here, we're going to look at proving the converse of alternate interior angles theorem, which basically means that if the alternate interior angles are congruent, then the lines are parallel. That's what we're going to prove, because once we prove it, we can use it. So angle 2 is congruent to angle 3. They gave that to us. So we can see it right up there in the given. So you're just going to write given. And mark your picture. Angle 1 is congruent to angle 3. Now remember, we don't know that the lines are parallel yet. But since angle 2 is congruent to angle 3, and we can see from our picture that angle 1 is congruent to angle 2. Okay? Angle 1 is congruent to angle 2 because they are vertical angles. So we would say vertical angles are congruent. Okay? Now, you can see 1 and 3, those are corresponding angles. Well, we know by the corresponding angles postulate that those would be congruent, but since the lines aren't parallel, we can't say that yet. What you can say, though, is since we already know that 2 is congruent to 3, and now 1 is congruent to 2, let me make that 2 a little bit bigger for you, then we can use our transitive property and say, since 1's congruent to 2, and 2 is congruent to 3, we know that angle 1 is congruent to angle 3. And this would be our transitive property of congruence. Okay. Now, since angle 1 and angle 3 are congruent, and we know that they are corresponding angles, we know that line L is parallel to line M, or N, because of when corresponding angles are congruent, then that implies that the lines are parallel. Okay? That's your converse of corresponding angles theorem, and you can just say when corresponding angles are congruent, the lines are parallel.